Welcome to a brand new video. Yo, let's do integration by parts, and the integral is the integral of cosine of x minus 1 over x squared dx. Cool, man. Now let's do it. So u is equal to 1 over x squared. Sorry. Nah, man, I don't want to make that my u. I want to make my u cosine of x minus 1. Du is equal to negative sine x dx, which means that dv is equal to 1 over x squared dx, which means that v is equal to, well, if I bring this exponent to the top, it's x to the minus 2, and then n plus 1 over n plus 1, that's minus 1 over x, yeah? Well, minus 1 over x. Cool. So now let's do it. So integration by parts one. So uv minus integral v du. I'm pretty sure we've got that by now. So u is cosine x minus 1, cosine x minus 1. V, that's times minus 1 over x. So I'll just negative over x minus the integral of v du. But v is just minus 1 over x. So this is plus 1 over x. And du is negative sine x dx. Oh, it's still v du, yeah, it's still a negative actually because of this stupid sine x homie over here. Sine x dx. I guess you could say the integral's looking better now. I mean, I've taken it from x squared to x, but I've swapped the trig sign. Alright, well, let's try it again. So let's u equal sine x, so u is equal to sine x. Du, well, we all know the derivative of sine x is cosine x dx, and that means dv must equal 1 over x dx. Well, the integral of 1 over x is the ln of the absolute value of x, so let's plug that chugga-lugga in. So remember, we still integrated the cosine of x minus 1 over x, and now that's minus this whole integral here, so minus, factored out, uv minus integral v du, so minus sine x uv, so sine x ln of the absolute value of x, uv minus the integral of ln of the absolute value of x, du cosine x dx. Oh, dude, this looks even worse. Now I've got the ln of x and the cosine of x. Well, I can't integrate ln of x unless I want to do integration by parts twice, so I have to let this equal u. So u equals ln of x, which means that du is equal to 1 over x dx, is the derivative of ln of x is 1 over x. So this is, I've done integration by parts twice now, so this is my third time around, so not your everyday example. So dv is therefore equal to cosine of x dx, which means that v is equal to sine x. So, well, let's rewrite the integral. So, it's still negative cosine of x minus 1 over x minus sine x ln of the absolute value of x minus bracket uv minus integral v du. So, ln of x v sine x minus the integral, sorry about the integral, I'm trying to squeeze it in, the integral of v du, well, that's sine x, and du is sine x over x dx. I don't know if you noticed though, but I had the integral of 1 over x sine x dx, and I've got it again, the integral of sine x over x dx. And sorry to burst your bubble, but this integral is actually not possible. Yeah, what a surprise. So here's how I know without using in a calculator. The reason why I know that it's not possible is, well, I had red flags when I had ln of x's and cosine of x's, but I also had red flags when I realized that my integral included like a trig function to the power of 1. Usually this involves a technique called Weierstrass substitution, also known as Z substitutions, but they're a lot more advanced than integration by parts. But the key to realize is that Obviously this is a red flag, ln of x and cosine of x. If that's your if this is your integral you have to compute, yeah, you should have alarm bells ringing that it's not possible. But the best clue to know that if you're doing integration by parts over and over and over again, and you find that you've got an integral that was the exact same as the integral as you had before, then that means that the integral's not possible. That's the biggest clue. Like, this is a red flag, as I said, but this is the biggest sign. So, yeah, this integral is actually not possible. If you type it in on an integral calculator online, you'll find that it's like a special integral. Like the integral sine x over x is actually a special integral called the SI of x. And yeah, if you want to assess that up yourself, I don't really know anything about it apart from its name. But yeah, that's the end of the video. So yeah, enjoy. So sometimes the whole point of this video was to show that you'll do integration problems, but not every single integration problem is possible. So I guess but don't blame that. Like, if you're doing an integral you can't solve, don't blame it on, oh, it's not possible. But sometimes it genuinely isn't possible, and that's what I wanted to illustrate here. Anyway, cheers.